Welcome, dear listeners, and normally I say dear viewers as well. This is John Consemulder for Healing Sound Movement Radio. And of course, we also do television. Go to healingsoundmovement.com for all other work and radio work. Go to worldpeacechild.com for our children project. This is quite a special recording because I just had my coffee. It's early in the morning here, but someone else is about to sleep and probably should already be sleeping for some hours. Mark McCandlish, go to his website, www.markmccandlish.com, Mark with a K, and then MCCANDLISH.com, so markmccandlish.com as one word. Mark McCandlish is an internationally recognized artist who has specialized in aviation and conceptual art within the defense and aerospace industries for the better part of his last 30 years, serving the needs of many of the top American corporations in this regard. His father was a 25-year veteran of the United States Air Force, and as a consequence, Mark has had a lifelong love of aircraft and aviation history. He also had a UFO sighting which occurred at Westover Air Force Base in the state of Massachusetts. But we'll talk some more about free energy and anti-gravity and zero-point energy and ether physics and scalar electromagnetics and torsion physics and you name it, because I know Mark is an expert in that field as well. And we also would like to invite him to a conference we will be doing in the future in our center. But for now, because we have a conference about chemtrails, geoengineering and HARP, and because of the time, it's quite late at your end, I'm going to say welcome to this show, Mark.
Thank you very much, John. I'm glad to be with you.
And thank you for taking the time at this late hour. So let's just start, not with your background. I mentioned a little bit about that. I will go into more depth in the future. But what have you experienced in the field of chemtrails, geoengineering, HARP? Of course, you have a history researching the aviation industry and the history of the airplanes. So what have you seen? At what point in time did you discover there's something else going on in our skies?
I think it was around the year 2000. I began to notice that there were a number of what we call persistent contrails here in Northern California where I live. I'm about 2.5 hours north of Sacramento in the city of Redding. And I had heard a few people talking here and there on the radio and other places about these so-called chemtrails. And honestly, I was rather skeptical in the beginning. But having been around aircraft most of my life, because my father was, going from one air base to another for his duty assignments, I saw an awful lot of aircraft, large-scale bombers like the B-52 and fighter aircraft and so forth. And so it had always been my experience that these condensation trails or contrails would dissipate within 30 seconds to a couple of minutes, but wouldn't last much longer than that. But the trails that were appearing over Northern California about that time in the year 2000 were not dissipating at all. In fact, they were spreading out and becoming larger, and as time went on, they would turn the entire sky completely white. And it was a few days after a particularly heavy campaign of this aerosol spraying that the local newspaper had a headline that said that dozens of patients had reported to area hospitals complaining of respiratory distress.
Yes.
And so that was when I began to notice that there was something else going on besides just moisture and condensation behind jet aircraft. And I have a close friend who is particularly sensitive to any kind of contaminants in the air, and she was complaining of a metallic taste in her mouth from the air. And so I began looking at this a little bit more seriously, and I started noticing that there were a number of individuals, Clifford Carnicom in particular, who had spent an awful lot of time analyzing what these trails might be made out of. And it turned out that they were finding particularly high levels of aluminum, barium salts, and strontium, which is a mildly radioactive element. There have also been occasions where, of course, you see silver and copper iodide for cloud seeding operations. We've even documented the use of things like sulfur dioxide, and lithium. And so I began to study whatever I could find within the publications from the defense industry itself. And one website that is particularly helpful, and many of your listeners might want to check this out, is the Defense Technical Information Center website, or DTIC. If you plug in a number of specific search terms like aerosols, or weather modification, or nanoparticles, or any sort of toxic effects, toxicology of aluminum oxide, nanoparticles, things like that, you will begin to find papers that have been written by scientists who are working for the military, working through the Pentagon, working through various research programs, most of which have to do with biological systems and the impact that various chemicals used by the defense industry have on the environment and living organisms. You begin to find that there is a very broad spectrum of research that has been done about the effects of these particular materials when they are distributed in the environment. And so one of the first papers that I came across was a study that was conducted at Wright-Patterson Air Force Base in Dayton, Ohio, between the years of 1993 and 2001. It was, I believe, it was cleared for public release in 2006, but it was about an 8 or a 9 year study where they were looking at the toxic effects of aluminum nanoparticles on the respiratory systems of rats. And the title of the article, the research paper, was In Vitro Toxicity of Aluminum Nanoparticles on Rat Alveolar Macrophages. Now, that's just a really fancy scientific way of saying what are the toxic effects of aluminum oxide nanoparticles, or aluminum nanoparticles, on the white blood cells in the respiratory tract of rats.
And
now,
the immune system, yes.
Yes. Well, you see, in the little air sacs that expand and contract when you breathe, when your lungs are expanding and contracting, those little air sacs are called alveoli. So when you talk about alveolar macrophages, you're talking about the white blood cells that are in those little air sacs that are there specifically to defend you against infections that might come into your system through breathing, through respiration. And so these white blood cells are your first line of defense against airborne infection from somebody next to you is sneezing on the bus or what have you. And so what the study said was that they determined that not only did these aluminum nanoparticles of particular sizes within a very short amount of time and a very relatively short amount of exposure would suppress not only the activity of the mitochondria inside the cells, which are they're little organelles, little symbiotic organisms that swim around inside the cells gobbling up toxins. But the aluminum nanoparticles would suppress the activity of the mitochondria, but it would also suppress the ability of white blood cells to swim up to and engulf pathogens. Now, that process is referred to in the scientific literature as phagocytosis. Mm-hmm. Phagocytosis is like when an amoeba consumes its meal, it swims up to and basically surrounds this target and then digests it by completely engulfing it. And that's pretty much the same thing that a white blood cell does. And so this exposure to aluminum oxide nanoparticles and aluminum nanoparticles would actually have an effect of suppressing the ability of the white blood cells to do what they would normally do to protect you from airborne infections and exposure to various toxins. So this was something that I found to be very concerning. And so I started looking at what the possible dynamic uses of nanoparticles distributed into the air as an aerosol might do. And there were plenty of documents to be found that had to do with weather modification, that had to do with affecting the ionosphere, that had to do with being able to enhance the strength of storms to make them more powerful, or to even suppress the formation of storms. That you could even control the direction of storms. Now, I know that there's probably some of your listeners who are very skeptical about the possibility of being able to do that. So I'd like to explain briefly how that's possible.
Sure.
Now, for example, if you and this is just sort of an analogy, but if you took and put a log in your fireplace for a fire to keep you warm, and you take a match and you try to light it, it begins to burn slowly and very, very slowly begins to gradually be consumed by the flames and produces heat. But if you took that entire log and you broke it down to the size of particles of sawdust, and you tossed a match on the pile of sawdust, it would almost be explosive. The chemical reaction of oxidation, of the burning of the sawdust, would spread through the material so quickly that it would release all the energy very quickly at a very short amount of time. And that's kind of what happens with nanoparticles. Instead of putting a big chunk of metal into the air, they take and put countless particles, I mean, literally almost an inconceivable number because they're so tiny. Now, to give you an idea of just how tiny the nanoparticles that they're spraying into the atmosphere are, if you had a beach ball that was representative of a red blood cell that you see going through your veins when your body is your blood's pumping, your heart's pumping, and so forth. You took a red blood cell. These particles are so small that you could line up 50 marbles next to that beach ball, and that would represent the size of these particles. So take a red blood cell that you can't even see without using a microscope, and imagine that you've got 50 tiny particles next to it, and that's what they're spraying into the air. And it's part of why these particles can float around in the air for such a long time, is because they're so tiny, they're just blown around by the wind, and they can be lofted by the mere fact that when they absorb radiant energy from the sun and they heat up the surrounding air, and this is getting back to the analogy with the sawdust, when they absorb energy from the environment, it has a tendency to increase the surface area of what you're talking about, because instead of one big chunk of aluminum, you've got billions and billions of little tiny particles that are all having an effect over a much wider area. So if you imagine that these particles are all identical in size, and this is a key point, if the particles are all identical in size, say 100 nanometers across or 50 nanometers across, and a nanometer is a billionth of a meter, these particles will resonate at microwave frequencies, the kind of frequencies that the military would use, for example. In fact, this is kind of where the technology came from, was in the early days of trying to avoid being shot down by a missile or having some kind of weaponry directed at your aircraft using radar. One of the first things that the military discovered, probably back in the 40s or the 50s when radar was coming into use, was that if you sprayed a bunch of shredded aluminum foil out the back of the airplane, it would create a cloud that would reflect the radar energy and produce a much stronger signal for the listening part of the radar system. And so you could fool the weapons system that was being used against you into shooting at that cloud of aluminum particles instead of your planes. So you had a higher...
Is that what they call chaff?
Yes, exactly.
Okay.
Very good. So you know about this. So the idea originated with chaff, the idea that you could put something into the air that would either absorb or be much more reflective of a particular type of radiation. In this case, the type of radiation that was being used to direct a weapon system. So, but eventually, companies like Lockheed discovered that if you made the particles of metal of a specific size, and they were all the same size, you could tune those particles, you could tune the size of the particles so they would resonate at the exact frequencies that were used by the radar systems in Russia and China back during the days of the Soviet Union. And so they developed something called iron ball paint, and iron ball really refers to these particles of metal that were sort of suspended in the paint itself, which was kind of a resin-based paint. And so what they would do is they would paint this pigment on the aircraft. It was typically sort of a black or a dark gray color. And what it would do was it would absorb those frequencies of the microwave radiation from the radars of these systems. And instead of reflecting it back into the environment, it would resonate and it would convert the radar, the microwave energy, to heat. And so it would reduce the amount of reflected energy that would go back to the antenna for the radar system, and so you had what was called a reduced radar cross-section. Mm-hmm. And so this was sort of the beginning, the birth of stealth. And so what they eventually discovered was that if you distributed these particles into the environment, that you could kind of do the same thing, but you could cover a much larger area and obscure the enemy's ability to see what you're doing. And this particular idea goes all the way back to the smoke screens that were used. Bags of material were dumped out the back of biplanes during the First World War to obscure the location of ships on the sea so that an enemy battleship could not target that vessel with their artillery. So
we're going from smoke screens to tele sunscreens, and we're going to stealth trails to chemtrails in a way.
It's true. It's exactly true. In fact, to point out just how effective this can be, there was actually a gentleman a few years ago by the name of John Consemulder, living in Florida. He was a television broadcast engineer who had a type of cancer, and he discovered that for whatever reason, nanoparticles of carbon and nanoparticles of gold are attracted to a particular type of protein that you only find in malignancies and only malignant cells. And so if you were able to infuse a dose of these nanoparticles into the bloodstream, they would be attracted to and stick to just the areas where these malignancies were, wherever they were in the body, a totally non-invasive process. And then by exposing the patient to a mild emission of microwave radiation that was tuned to the exact size of those nanoparticles, you could heat up the tumor cells only. And at a temperature of about 135 degrees, you will kill the tumor cell. But because tumor cells are not as robust, they're not able to withstand heat as well as normal tissue, the tumor cells would die and the surrounding tissue would remain unharmed. And so he found that this was a way that you could actually eliminate a tumor from the body and have the immune system, the white blood cells in the body, consume the dead necrotic cancer cells after they had died from exposure to this heat. And then, of course, the heavy metals, the carbon and the gold nanoparticles would be taken out through the urinary tract eventually as well. And there's processes for doing that. The only drawback for that particular type of system is that, of course, if you have a very large tumor or if you have a larger number of tumors, if you kill off too many of the cancer cells all at once, it'll overwhelm the kidneys and you'll go into kidney failure. So it has to be done incrementally, and it has to be done in a very careful way. But I believe that they're getting ready to start up some clinical trials on that in the near future. But this was one way of showing that if you put a lot of particles of a particular size into the environment, sprayed out the back of airplanes, that you could then broadcast a signal at that particular part of the sky, and you could cause the nanoparticles to resonate at that frequency and heat up the surrounding air. So when you look at the size of the particles themselves, the particles are small enough that they actually become what you might refer to in meteorological terms, condensation nuclei. They're so small that the water in the air will condense on these little tiny nanoparticles in the air. So then you hit them with this microwave emission, and it heats up the particles and it heats up the surrounding air, and so you form what is called a convection cell. So not only is the air expanding, but it's also rising to a higher altitude because of the temperature. And what it does is it carries all of that moisture up to a higher altitude, where of course it freezes or condenses into a powerful low pressure system. So this is one of the ways that you can actually form a storm, or by repeatedly hitting an air mass with this particular frequency of microwave energy. Granted that you have to know what the size of the nanoparticles are that were used in the original distribution of the aerosol. But if you know what that particular size or group of nanoparticles is, then you can continually loft that air mass up into the sky over and over again. You can actually sort of perform a conveyor effect, where the moisture that might ordinarily drop, say, here in California, is carried much further downrange to, say, Ohio or Mississippi or Missouri. And then if you allow it to, you can cause it to condense and drop out all at once and cause flooding. So one of the things that we're seeing here in the United States, and this is probably happening in Europe and other places as well, is that you're seeing places that ordinarily would get a fair amount of precipitation, getting rain, not getting the amount of rain that they ordinarily would be expected to. But places that are further downrange that might ordinarily not expect to see a lot of rain are getting too much. They're getting flooding. And so this is one of the ways that you can militarize and weaponize the weather so that you can actually cause effects in the environment that can either be helpful, as in getting enough rain when you might not expect to, or getting too much. And if you get too much, of course, you get flooding. And this, from a military standpoint, of course, has a great tactical advantage for two reasons. One, it looks like an act of God, and so it's really hard to point a finger at anyone in particular and say, oh yeah, it's their fault. But what you can do is create a situation that's referred to in military circles as asset denial or battlefield denial. So the enemy is not really able to move as effectively within the environment to accomplish whatever their tactics or whatever their plans are for a particular engagement.
Yes, and nature creates perfect plausible deniability, right?
It really does. I mean, because people, at least for the most part, people who understand what the technologies are and what these capabilities are pretty tight-lipped about what the potential uses might be, but the general public doesn't really believe that it's possible to, send a beam of microwave radiation into the air and cause a storm to get worse or to be reduced in its severity. And there's several ways that you can do this. You can steer the path of storms, and I'll explain to you how that's possible. For example, if you have a number of planes that are going back and forth across a particular area and spreading a pretty heavy aerosol dispersal of aluminum nanoparticles, which are white for the most part, whether in the sky, highly reflective. It raises the albedo of the environment so that you don't get as much solar radiation that's reaching the surface of the Earth. And so the air mass that is below that particular region will be much cooler. And so because it's cooler, it tends to sink and basically shrink in size. It contracts, and so the surrounding air that would be around the perimeter of this region is all drawn into that area. And at the same time, you might take another set of aircraft flying in an adjacent area that are dispersing nanoparticles that are of a slightly different size, which would respond to an entirely different frequency of microwave radiation. And this particular area, you bombard it with this particular frequency of energy so that the air mass expands and it rises. And so you also have other things like the Coriolis effect, which is caused by the rotation of the Earth more or less dragging the air along with it as it turns, and so, or rotates. And so what happens is you see that low pressure systems in the northern hemisphere of the Earth tend to spin counterclockwise, and high pressure systems tend to spin in the opposite direction, going clockwise. And so if you have these two systems right next to one another doing this process of contracting or expanding, is like two gears that are next to one another with their teeth engaging one another. And so you actually get this acceleration that happens between the two air masses.
So resonance and amplification effects.
Well, it can be, yes. And so in this way, you can cause a region of the air to move along very quickly between these two systems, between the high pressure and the low pressure system. And by strategically placing where these particular dynamic effects are influencing the environment, you can actually steer the jet stream. You can steer the course of a storm. If you want a storm to move in a particular direction, then you spray some aluminum nanoparticles out in front of it, which cools the air in that region and contracts. It contracts, and so it draws a storm in that direction. If you want to move a storm away from an area, you can do the same thing. You spray nanoparticles that have a particular frequency and bombard them with the microwave energy, like from a system like HAARP, which we can get into in a minute. And it causes the air mass to expand, so you can actually push a storm away from a particular area, protect a particular area by causing the air mass to expand. So
I think in the meantime you need a glass of water. I can hear it from your voice.
I do. If we could pause for just a second, I would like to do that.
Sure.
Would that be all right?
Yeah.
Okay. I'll be right back.
Sure.
Oh, that's better.
I thought so. I could hear that.
Yeah, it was sneaking up on me there, and I just apologize.
No worries. You want to continue, or you want me to ask the next question?
Yes, go ahead and ask the next question.
Okay. Now, Mark, I've been talking to many people, but for instance, Susan Joy Renison and Pyotr Gardiev. I also remember the work of Dmitriev. So that's a work of space weather, where actually all the carbon dioxide problems we have, and we tax the human beings, but we could as well tax the extraterrestrials because it's happening on other planets as well. So maybe our contributing factor to warming up this planet is, in all truth, immense, but at the same time, maybe this whole global warming thing is because of the chemtrails and of the ionospheric heaters like HAARP, and I trust there are many more of them worldwide, that are warming the atmosphere with, I believe, 1,000 degrees microwave radiation wise. So and then the space weather condition, where we have all these zero-point energy fluxes and changes of electromagnetic background radiation, so to speak. So what's your opinion if you relate chemtrails and geoengineering to global warming? So A, is it happening? B, is it happening because of us, or mainly because of those weather warfare and weather manipulation interventions, or maybe together with all these space weather fluctuations? What's your opinion?
Well, it's a combination of many different factors. There's a lot to consider. For example, the same aluminum nanoparticles that can be used to reflect the sunlight away and reduce the temperature of a local area by blocking the sunlight from reaching the surface can also be used to hold the heat in. Say, for example, if you spray California, an area that's west of your target area, in the early part of the morning. And we know that the global weather patterns in the northern hemisphere move from west to east because they're being dragged along by the rotation of the Earth. So let's say, for example, that this is a particularly hot day in Arizona, which is just to the east of California. And so you have this really, really hot day in Arizona, and then over the course of the day, all of this aluminum that's been sprayed over California drifts into the region that's been heated up during the day by the sun in Arizona. And so what it does is it tends to trap that heat below this layer of aluminum. It reflects in both ways. It reflects sunlight, heat back out into space, but it also reflects the heat or holds it in particular areas. So you can actually use this in either way to enhance or to exacerbate a meteorological condition that may or may not be desirable. Say, if you wanted milder weather in the northern latitudes at a particular time of the year, one of the ways that you can do that is to spray a region that's immediately to the west of wherever it is you want to retain this heat. Say perhaps your desire is to melt off a lot of the polar ice cap at a particular time of the year so that the sweet crude oil deposits on the sea floor are much easier to get to when the temperatures are a little bit easier to take, and you can move ships into the area to harvest this oil, floating oil platforms and so forth. In fact, even the Russian military has been sort of staking out a lot of the North Sea areas, the Arctic Ocean, that are being freed up in the summertime by these warmer temperatures. Now, there's a little bit of an explanation required to understand what's really going on with some of these different processes. For example, in the Atlantic Ocean, you have the Gulf Stream current along the eastern coast of the United States, which goes from the equator where it's really warm, and it moves north towards Greenland, Iceland, and of course it's responsible for helping to keep milder winters in Europe because of this warm current that comes up the coast of the United States. But what's happening, though, is because the average global temperatures are much higher in the summer than they have been over the previous century or so, you're seeing a tremendous amount of glacial ice and snow that's melting off in the Arctic, particularly in large land masses like Greenland, for example. And this ice and snow, of course, is condensed, or I should say desalinated water. It has no mineral content to it, and so its specific gravity is much lower than seawater, which has all the minerals dissolved in it that gives it the salty taste. So what happens is the cold, fresh water that's coming from the snowmelt and the melting of the glaciers in places like Iceland and the Arctic and Greenland, these areas are pushing this fresh water out into the ocean, and because it's very cold and because it has almost no mineral content, it's floating on the surface of the ocean because it has a lower specific gravity. It's more buoyant, essentially. And so what happens is the warm, mineral-laden currents or water that's coming from the equator is much heavier because it has a higher mineral content, it's have a higher specific gravity, and so the cold fresh water on the surface is causing the Gulf Stream current to subduct. It's causing it to go down to the ocean bottom, and it's beginning to sublimate and melt off the methane hydrate deposits that are on the sea floor in the North Atlantic, particularly in the Labrador Sea, which is between the northern part of Canada and Greenland. And so what you're seeing is that not only is the problem with carbon dioxide and global warming being exacerbated, but methane itself, when it gets into the atmosphere, has a much higher ability to retain and hold heat in the atmosphere than carbon dioxide does. And so it's much more harmful in terms of what damage can be done with global warming. But the sort of the one thing that would cause people to think that global warming is a hoax and there's nothing really going on is the fact that this cold mass of fresh water that's in the North Atlantic from all this melt-off in the summertime is producing much colder surface temperatures. And what happens is that the air masses that flow across the North Atlantic that are exposed to this cold water cause a much higher level of condensation. You see much more precipitation and cold storms. You see colder winters throughout Europe and the northwestern part of Russia in that area. And so people say, well, the weather is so much colder in the wintertime, there couldn't possibly be something like global warming going on. But it's really just a temporary effect, because in the long run, the cycles are going to oscillate towards much hotter summers and much colder winters up to a certain point. And then, just like these little experiments we did in school, in our science class, where they talk about the latent heat in a glass of water with some ice cubes. Once you get to a certain threshold point, all the ice melts very quickly. And once that happens, you're going to see a dramatic rise in sea level.
So, non-linear tipping points, so to speak.
Yes, exactly. You're exactly right, John. So this is the thing that I'm really concerned about, because I really believe that even though there may have been, and you have to understand, there's these programs, the aerosol programs that are being conducted worldwide must be enormously expensive. They must cost hundreds of millions of dollars, not just in the cost, the operational costs of all the aircraft that are involved, but just the production of nanoparticles alone since the early 1990s has gone from a multi-billion-dollar industry to billions of dollars annually. If you start looking on the internet for the companies that are responsible for producing nanoparticles of different sizes and different kinds of materials, you'll find that the science and the research into what these particles can actually do is expanding exponentially. In fact, they even have different kinds of nanoparticles that have a core of one kind of material and an exterior of something else, like something called the oxide-coated nanoparticles of aluminum oxide. And so one of the things that you find, one of the papers that I located was a presentation put forth by some researchers for NASA, the National Aeronautics and Space Administration here in the United States, that described taking different kinds of propellants, not only for rockets and military weapon systems, but also for aircraft, and using silica aerogels, which are extremely lightweight, and combining them with metallic nanoparticles. And by choosing carefully which kinds of materials you use, for example, putting strontium, which is used in pyrotechnics, and barium salts, which are also used in nanothermate, which are high-temperature explosives, like the kind that brought the World Trade Center down. And as far as I believe, that they found the residue from these particles, these materials in the debris of the buildings. But you put this and aluminum oxide nanoparticles, or oxide-coated aluminum nanoparticles, in jet fuel itself. In one case, 40% by weight, but usually less than that. What you find is these nanoparticles are so tiny that when they are brought into the combustion process, they essentially vaporize because they absorb so much of the heat from the reaction, but they also release all of the oxygen into that reaction, so they make combustion much more efficient. And the gelation, or the gelating, the silica aerogels that they put into these fuels are intended to reduce the amount of sloshing around in the fuel tank that you see. It helps to control the progression of a fire in the aircraft if there's a crash or a mishap of some kind. But there's other advantages that you see with this particular kind of process when you put aluminum oxide nanoparticles and some of these other chemicals into these gelated and metallized fuels. You find that because you're more or less carrying an oxygen supply right in the fuel itself, albeit completely inert, what you're allowing is you're allowing the aircraft to be able to fly to higher altitudes where there's less oxygen in the environment itself. And so you don't have to rely entirely on how fast the aircraft is going or how much air you can gulp into the engines, because you're introducing the air into the combustion reaction that produces the thrust right in the fuel itself.
So you're almost surfing the ether wave, so to speak. Yes.
Exactly. I mean, in fact, this is probably the kind of thing that would allow aircraft like the top secret Aurora aircraft to operate as an air-breathing aircraft at much higher altitudes, 75, 85, 100,000 feet or higher, where you don't have a lot of air. And those particular aircraft rely on high speed to be able to gather up enough oxygen to sustain the combustion reaction that gets them going so fast. But in the case of a conventional aircraft, the only real difference that you have to be concerned about is that the control surfaces, the flaps and the ailerons and all the rest of it that are on the wings and the tail and so forth, they have to be a little bit larger to be able to maneuver the plane where the air is so much thinner. So like some of the more advanced aircraft that we see today, like the SR-71 Blackbird, for example, which has now been retired, but the entire vertical stabilizers on that aircraft would move. And so it was a much larger control surface because it was operating at a higher altitude where the air is so much thinner. But if you're able to put the oxygen supply right in the fuel itself, it allows you to travel much more efficiently because, number one, if the air is thinner, it means it provides less friction, less air resistance, so your plane can move along much more efficiently, especially if you have the oxygen right in the fuel itself. But if you're doing this as a consequence of putting a metallic particle like aluminum oxide nanoparticles in the fuel, of course, one of the fallout materials from that operation, the operation of those jet engines is, of course, going to be aluminum. Now, most people are not familiar with this, but one of the things that you have to do when you're welding aluminum is you have to be able to shield the flame, so to speak, of the welding process with an inert gas rather than something that has oxygen in it, because it's like heliarc welding, where you're using helium or argon or some other inert gas, because if you have oxygen near molten aluminum, it immediately combines with the aluminum and produces a much more porous, a less strong, not as robust kind of a weld. And so this is part of what happens when you put aluminum oxide nanoparticles into jet fuel, is that when that aluminum comes out the back end of the jet engine as a vapor, it almost immediately recombines with the oxygen in the environment. And so that's what you see falling out of the sky in the form of these microscopic particles, is aluminum oxide. And so this is evidence that it's being used, at least partially, as part of the combustion process. Now, one of the things that
so do you mean to say that the evidence we can deduct from the transmutation of alchemy process, if you will, from what you just described as the process of actually producing aluminium and the way it's being used now?
Well, the aluminum that's being put into the fuels or being used for the chemtrails, the geoengineering process, when it goes through the combustion process, and this is a completely normal process that you'd see in everyday chemistry involving metals. It's not any kind of an alchemy sort of a thing, so to speak. It's just basic science is all it really is.
Chemics. Yes.
But you have to remember that this is one of the reasons why aluminum oxide nanoparticles, along with sulfur and iron oxide and some other things like barium, are used in nanothermates, the kind of explosive, high-temperature explosives that are used to bring down skyscrapers in controlled demolition. Because when those explosives are set off, they release so much oxygen so quickly that the temperatures become very, very hot, like an oxyacetylene welding torch. And this cuts through the steel beams very quickly in just a fraction of a second, and that's what allows the building to collapse straight down into its own footprint. Now, the problem is, of course, that when you're spraying this stuff in the air because you want to control the weather, or you want to steer a weather system, or you want to be able to manipulate where the water will go, where it will fall, where it will not fall, one of the problems is that the aluminum oxide that's getting into the environment is small enough, the particles are small enough that they're being absorbed right into the plants. It suppresses the germination of plants. And so Monsanto, for example, has actually developed and patented a number of plant strains, crop plant strains, that are aluminum resistant.
Yeah, the Terminator seeds.
Yes, well, that's part of it. But the real problem is that these areas that are being sprayed, particularly here in California, is a great example, because you have a mountain range along the coast of California. You have another mountain range between California and Nevada, which is called the Sierra Nevada mountain range. But these are areas, what they call local areas of regional instability. That's one of the terms that you see in the meteorological texts describing what happens to the weather in this area. But basically what it does is when the air is moving along the surface of the earth and it encounters a mountain range, it's pushed up to a higher altitude, of course, where it's very cold. And if you have moist air that's coming in off the Pacific Ocean that's full of lots of humidity, it's pushed up to a high altitude, so you generally expect to see clouds forming above those mountains, very often lenticular clouds that look like flying saucers and all the rest of it, but you see these cloud formations that begin to form there. Well, this is exactly where they're also seeding the clouds with these aerosols, because it churns everything up, and so you have a better distribution, so to speak, of the particles into the atmosphere. And then, of course, when the air mass encounters the second mountain range of the Sierra Nevada, which is just to the east of us here, you see the same thing happening again. So it's not unusual when these aerosol campaigns are occurring here in Northern California to wake up in the morning to a clear sky and by 9 or 10 a.m. to see 35 or 40 aerosol trails running the length of the state, going from north to south. And these are not just commercial airliners, although I will tell you that the aircraft that I see blowing these aerosol trails, more often than not, are Boeing 737-800 model aircraft in the Southwest Airlines livery, which is kind of surprising, but that's what I've seen with my own eyes. So the problem is, and this is what I was coming to, was that this aluminum oxide, when it gets down to the ground, when it eventually settles out from the atmosphere, very often settling at the higher altitudes in these forests, the forests absorb the aluminum nanoparticles that have this oxide coating because of the combustion process in the engines of the jet aircraft that it comes from. And the other problem that you have to remember, is the aluminum is a conductor of electricity. And so when you have all these particles floating around in the air, it also raises the ability of the air to conduct electricity. If there's a storm that happens, if a thunderstorm begins to form over the mountains, as is typically the case in certain parts of the year, like in August, September around here, we see a lot of thunderstorms. So you see a much higher number of lightning strikes. And of course, when the lightning hit the ground and it strikes in these forests, particularly after a drought like the one we've had for the last 3 or 4 years, you see forest fires caused by the lightning strikes. But remember that this is a forest that spent probably the last 10, 15 years absorbing all of these aluminum oxide nanoparticles, which means that the forest fires are much hotter because you're seeing the same chemical reaction that you would see in a thermate explosive. You're seeing the aluminum, the barium, and the strontium, which are all used in pyrotechnics, and it's being consumed and releasing all this oxygen during the forest fire. And so the forest fires are much more aggressive. They're much harder to suppress.
Because we are ionizing the atmosphere, so to speak.
Well, part of the problem is that when you have metallic particles in the air and a lightning strike occurs, there's an electrostatic potential that builds up when the air is swirling around and you have these particles. It's like static electricity, like when you're walking with a brand new pair of leather shoes across a particular kind of carpet and then you touch something, you get electric shock. And it's because you've built up an electrical potential by moving along with this particular kind of material on your feet. And this is kind of what happens in the sky. You get this electricity that builds up. And one of the things that we always see with thunderstorms is that there's usually lightning strikes that occur before the rain begins to fall out of the clouds. And so the problem is, of course, that if you've got all this aluminum, barium, and strontium that's in the environment and a fire starts, the fires are much harder to put out. Now, of course, what do fires produce? Carbon dioxide, and lots of it. But they're also producing a tremendous amount of soot. Now, there's a scientist by the name of Jason Box who's been part of a project, a research project up in the Arctic for the last almost a decade, I guess. It's called the Dark Snow Project. And his theory is that these fires, one of the things that we see because of the prevailing weather patterns is that the soot from these fires is being circulated up into the Arctic, and it's actually reducing the reflectivity of the snow. So the snow is now melting at 3 times the rate that they thought it was before. It's melting 3 times faster. And so this, of course, is a big problem. And so you can imagine that if someone, with the international or the Intergovernmental Panel on Global Climate Change looking at this saying, well, geez, we're seeing all this carbon in the Arctic, we've got to put more aluminum oxide out there to reflect more sunlight to keep the temperatures down. And in effect, what they're doing is they're exacerbating the problem because it's going to cause more forest fires, it's going to cause hotter forest fires, and we'll see more carbon dioxide and more soot in the Arctic as a result. And so by messing around with
this is because they do not completely understand the dynamic and organic and nonlinear feedback loops nature provides?
Well, you may be right. It's hard to say exactly whether this is intentional or whether this is the unintended consequence of experimentation that's just really kind of gotten out of hand.
Sure.
And it's hard to say because I try to imagine all of the reasons that a group of scientists with essentially an unlimited budget would sit around and say, okay, what if we do this? What will be the outcome? Will it stop global warming? Will it slow it down? Will it enable us to keep the water in the oceans and on Greenland and Iceland frozen, northern Canada frozen, so that we don't see the permafrost collapse? We don't see the melt-off of all this fresh water that's going to dramatically change the dynamics in the ocean, which will push the different currents like the Gulf Stream current to the floor of the ocean, causing the melt-off of the methane hydrates. Because once that happens, you're going to see an acceleration of the heating up of the northern latitudes, which, of course, in turn will cause the melt-off of the snow to become even faster. Now,
By the way, Mark, if you mentioned permafrost. If permafrost is collapsing, it's quite a misnomer then.
Well, it is sort of, yes. It's no longer permanent. In some areas of Canada, for example, the permafrost is almost 150 feet thick. It has a biological material, animal and plant remains going back almost 250,000 years, 250,000 years, that has never decomposed, has never released its methane or its carbon dioxide into the atmosphere. And so as the temperatures in those northern latitudes become greater and greater, you see the permafrost not only in the North American continent, but all across Eurasia is beginning to melt off too. And it's, of course, many of the forests that are in these areas are actually bedded down into, it looks like basically a mixture of mud and snow. And so once it begins to melt, and it begins to cause a kind of decomposition process, just like if you're composting the shavings from your lawn. As the decomposition process begins to accelerate, you see warmer temperatures in the permafrost, so it begins to cause a dramatic meltdown. And as that happens, the forests that are rooted on the surface of the permafrost, that are still able to gather nutrients from what soil there is there, that process is causing the collapse of the forest. And of course, as the forests die, they're releasing all that carbon dioxide as well. So it's a process that will not only produce more carbon dioxide, but because of the decomposition of all the organic matter that's in there, you see other chemical processes that produce different kinds of acids like carbonic acid and other things that will then react with things in the soil like limestone and stuff. And this in turn produces even more carbon dioxide. So you see all these processes that begin to accelerate and snowball to begin to increase exponentially. And I, when I look at this, and I hear my conservative friends here in the United States scoffing at global warming, and the people are falsifying their data, and it can't possibly be true. I'm actually embarrassed because it's as though they're completely ignoring the science of what's going on around us. And so when I see the aerosol campaigns that are being waged in the environment, I hope and I pray that whoever is doing this is making a genuine attempt to try and stall or to slow down global warming. But I think that there are probably some unforeseen consequences that are occurring as a result of these programs, and they're now trying to rethink what they can do. I mean, mankind has been so irresponsible with the way that we've treated the planet. I look at a country like Ecuador, for example, where in 1940, the entire country was almost entirely rainforest, and now here we are, 60 years later or so. 70 years later, and 95% of that rainforest and all of its carbon dioxide sequestration is gone. It is gone. It has been cut down and turned into farmland for grazing cattle and so forth. And this is the kind of thing that's going on all around the world because of an exploding human population. So you begin to wonder when you look at that research paper I described before about the toxicity of aluminum oxide nanoparticles and how they affect the immune system and suppress your ability to defend against airborne infection. I begin to wonder if maybe, of course, a lot of my conspiracy theorist friends believe that this is something that they're doing to try and kill off the human race, or at least a good part of it, so that the population won't expand much beyond the 7 billion people that are on the earth right now. I don't know that I agree with that, but I can see that if these programs continue unabated the way they're going right now, that may be one possibility.
Yeah, we have genocide, but we might have aerocide in this case, intentional or because of the consequence without using that intention. But one last question, because I read in the book Chemtrails Confirmed by William Thomas about space bugs that were actually eating aluminum, nano-sized bacteria, other life forms even tinier than bacteria, are thriving in our atmosphere. Robert Falk's work is mentioned there. So what do you think, what about the fungal and possible viral components of chemtrail contamination? If not deliberately introduced into a climate modification program, could malevolent microorganisms be piggybacking on the plumes?
Well, that's one possibility. I mean, there's a lot of people that have tried to tie a relatively new disease called Morgellons syndrome to the chemtrails. That they believe that there are components in the chemtrails that are intended to spread this particular disease process. I honestly don't know enough about that to really speak with any authority, but what I can tell you is that when I looked up whether or not aluminum nanoparticles would have any detrimental effect in an aquatic environment, there was a paper that I found. It was I believe it was called the International Journal of Aquatic Toxicity. These are the search terms that you generally want to use when you're looking for this stuff on the internet: is toxicity, aluminum nanoparticles, and various scientific journals. But what they were saying was that one of the particular algae that you see in freshwater streams, like chlorella, is devastated. It's killed off by these aluminum nanoparticles. It has something to do with stripping ions off the outer cell wall, which causes the collapse of the cellular structure of these single cell organisms. But these are phytoplankton type organisms. These are single cell plants that are taking carbon dioxide out of the environment that they breathe in. Same as we breathe in oxygen, and they breathe in the carbon dioxide, and they release oxygen into the environment. So when you look at the extent of the forest fires internationally, United States and Russia, Australia, and other places, you look at how this will impact the phytoplankton in the sea that produces so much of the oxygen that we breathe. You can see where, in a way, this is almost like a kind of a terraforming process that's changing the entire surface of the planet. Mm-hmm. It's very frightening. I mean, from one perspective, when you think about, if you can put iron oxide nanoparticles into the ocean, that it dramatically increases the growth of certain kinds of phytoplankton in the ocean. But if you put aluminum in the same water, it'll kill the phytoplankton. So these are things that, and I'm not really sure that it is a good idea for anyone to be experimenting with things on the scale that we're seeing right now worldwide.
Mark, while we are not being sure, because I agree, some comments I get from people, and I can understand this logical question is, well, I don't believe it, and who is doing it, and why would they do that, and why is necessary? And then the question comes, of course, which sounds very logical. They say if they are doing this, they need to breathe air as well, so they would die as well because of the consequences.
Well, that may be true, except that I can certainly imagine that there is a very select group of people with a tremendous amount of funding behind them that could build environments that are perhaps underground and are completely shielded from the problems with the environment on the surface of the planet, with entire systems that are able to recycle water, to split the water molecule into oxygen, pure oxygen, and hydrogen, using the hydrogen for fuel. Then, of course, in the combustion process, the hydrogen and the oxygen recombine into water, which you can then use for other things. So, it's entirely possible to create self-contained environment or environments, large environments that exploit this kind of a system that could be completely isolated from the surface for perhaps even decades, if that's what is needed. But I have to believe that, as you were saying, that their kids breathe the same air as our kids do, and you would hope that that the end result would be one which staves off global warming, at least until some of the activity on the sun seems to calm down, because I think that there does seem to be a connection between what's going on with the sun and the amount of global warming that we're seeing. But I also think that the widespread use of fossil fuels and burning of coal in places like China, that this is having a very big negative impact on the environment as far as the production of coal.
Yes.
I mean, I have a friend who's a time analyst who travels with some regularity to China. He's been to Beijing on other occasions besides when the Olympics was going on over there. And he said that most days when you're in Beijing, he says the air pollution from cars and from coal burning power plants is so bad you cannot even see the buildings across the street out your office window. That's how bad it is. So that should give you some idea. I mean, people, it's not unusual to see people wearing some kind of breathing protection when they're walking around town outside. And so this is what's going on in countries that are not seeing the same level of development that we have in parts of Europe and the United States and other locations. But I think that sooner or later, all of that material, that pollution, whatever it is, gets distributed throughout the whole environment. I mean, if you look at all of the oil fires that happened during the first Gulf War, that were set off as a sort of a strategy to slow down the progress of the Americans and their allies in the Persian Gulf War. Some of those fires burned for the better part of 6 to 9 months before they were put out, and released a tremendous amount of carbon dioxide into the air, and it affected the weather worldwide. Just like the Mount Krakatoa down in Indonesia in the early 1800s produced the potato famine across Europe, because it reduced the amount of sunlight that was reaching the surface of the earth for a number of years. People starved to death because of that volcanic eruption. So you can see that it's possible to put things into the air that will have dramatic impact on not only local areas, but areas that are completely around on the other side of the planet eventually.
Some people are even defending the position that we need to act now with geoengineering, because they say, well, the planet is already dying, and in fact, even if we would stop all this pollution right now, because of all these feedback effects and amplification effects we created and are still going on, it might still be dying, although we would stop completely now, which isn't even possible. So that's of course the bad situation, but then again, this needs to be stopped probably if we want to save the planet. But other people are saying no, we shouldn't stop this, we should reinforce the geoengineering project, because otherwise we can't live here any longer on this planet.
Well, I think that it may be a matter of just finding the right kind of materials to put into the atmosphere. For example, silica, in the form of nanoparticles, but polished little spheres, would almost be like the little tiny microspheres that they put in that reflective paint that's on the highway. It would be very reflective of sunlight, and yet silica, of course, is almost completely inert in terms of its effect on the environment when it drops out of the sky. And so that would be the kind of material that I would advocate if you're going to do this sort of a process, if you're going to be mounting an aerosol campaign in the hopes of slowing down global warming and the rising of sea levels and so forth, that you want to use something that's a lot more inert than aluminum or aluminum oxide nanoparticles. That's just a personal belief. But I think the real question that remains to be answered is exactly who is it that's doing this? Mm-hmm. And I haven't seen a satisfactory answer to that question. I mean, there's a lot of evidence to suggest that of course the military has found all sorts of applications for this kind of thing, as I pointed out earlier. But you would have to believe that in order for this to be going on worldwide, that there has to be kind of an international consensus on the part of not only the leaders but the scientific community, that there's something about this process that someone finds desirable. Otherwise, they wouldn't be doing it. They wouldn't be spending billions of dollars a year on this stuff. So, that's that's kind of my observation with what I have in the way of information right now.
I believe Michael Murphy, who of course produced What on the World Are They Spraying and Why, was about to work on the question, who in the world is spraying? So it might be interesting to talk to him as well.
Yes, I would suggest that if you have the opportunity that you do talk to him. And I would also like to suggest that you speak to my personal friend Dane Wigington, who runs.
I just interviewed him 2 days ago.
Oh, did you?
Yeah.
Did you really?
Yeah.
He's a terrific guy.
Great
I really
talk.
love Dane.
Great talk. Yeah.
And he lives about 15 miles from where I'm sitting right now.
Okay.
But he used to work for Bechtel Corporation in one of the divisions that was responsible for producing photovoltaic cells, solar cells. And so his entire house, he lives off the grid, so to speak. He's not connected to the local power system, and his house is covered with all these photovoltaic solar cells. And he has said that when these aerosol campaigns occur, that he sees as much as a 60% reduction in the amount of electricity that he's able to get from his solar panels.
Mm-hmm.
And that, so it also makes you wonder if there isn't some sort of ulterior motive on the part of the power industry to make sure that solar power isn't something that takes off and becomes very popular. But that just seems far too sinister for me. I can't imagine why someone would want to block the use of a renewable resource like that doesn't have any negative environmental impacts, as far as its use is concerned. So,
sure. Well, let's just end this talk by stating, postulating that sustainability comes in many forms, also in our consciousness and the way we want to treat this planet, because in the end, I think it also boils down to something fundamental about who we are. I have this author, Clive Hamilton. The book is called Earth Masters. I like to quote this. He says in his preface to the book, so geoengineering is not just a technological problem, nor even an ethical one as usually understood. It goes to the heart of what it means for one species to hold the future of a planet in its hands. So the deeper question is, what have we become?
Boy, that's a very remarkable statement. I couldn't agree with him more.
Well, Mark, I would like to thank you for this long talk, because as our listeners maybe did not understand yet, it was early at my end here in the Netherlands, but over there in the US of A, I believe it's quite late in the night, so you took the time especially to get this out because of our chemtrails and HARP, and we didn't even talk about HARP. We could have done it next time. But yeah.
If you do have just a quick minute, I would like to touch on that.
I have the time. It's you that has to decide when you want to go off to sleep, so to speak.
Well, I'll tell you what. Let me just touch on HARP very quickly. The acronym, or the word HARP, it's spelled HAARP, stands for High Frequency Active Auroral Research Program. Aurora, or auroral, refers to the aurora borealis, and the ionization that occurs in the upper atmosphere because of these high energy particles that come from the sun, from the solar wind. And so when there's a lot of sunspot activity, where magnetic storms and so forth that occur on the sun, you get these highly charged particles that come in the direction of the Earth, and when they impact in the higher altitudes of the atmosphere, they produce the aurora borealis, which looks like these colored curtains. And I mean, I remember when my dad was stationed over Ramstein Air Base in Germany back in the 1960s, we traveled up to Sweden, Norway, and Denmark, and there was so much solar activity at that time that we were actually able to see the aurora borealis during the daytime in the summer. So that was pretty impressive for me as a little kid back then. But as far as HARP is concerned, you're talking about what is called a phased array. Now it sounds real technical, but really all it's saying is that you have a network of antennas. And these are antennas with, a sort of two masts that are at right angles to one another. They're all exactly the same height. They're laid out on a perfect grid of squares with an antenna at each corner of the squares. And there's something somewhere between 70 and 100 antennae, I believe. And each one of these antennae produces a certain wattage of high frequency microwave energy. Now, the idea is that each one of those antennas, when it broadcasts a signal, that signal goes out in all directions like an expanding bubble. So if you are able to time the signal that is emitted from each one of those antennas down to, a very, very small fraction of a second, literally a billionth of a second, you can set up a situation where all of the signals from each of those antennas will arrive at some distant location at exactly the same moment. So all of the energy will basically it'll come into alignment. It'll come into phase, so to speak. Like if you drop two pebbles into a smooth, calm puddle of water at the same exact time, you see the little waves that radiate out from each one of the little pebbles that hit the water, and where those concentric rings intersect, you'll see an interference pattern. So imagine then that you have maybe 50, 75, or 100 antennae that are all emitting a signal at a very, very controlled, very precisely timed sequence. You can make all of the energy from all of those antennas arrive at a particular location at exactly the same moment and essentially unleash the totality of all that energy at one time. Now, this becomes very important when it comes to controlling weather. For example, if you want to heat up the ionosphere by putting an electrical charge into the environment using a system like this, or by heating up the atmosphere by having all of this energy arriving at a particular location at the same moment, that would be one thing. You can actually, even in the patents, it describes the ability to alter the path of intercontinental ballistic missiles by causing the ionosphere to raise up to a higher altitude that's not anticipated by whoever may be launching the weapon system. And so it creates an unanticipated amount of drag on the missile, and it causes it to go off course and theoretically not hit the intended target. But one of the other things that you can do, of course, is if you add to that the idea that you have countless nanoparticles of a very specific size, which responds to a very specific frequency in a particular region, and you want all of those nanoparticles to absorb and re-radiate microwave energy as heat into the environment, you can literally produce an extremely powerful low pressure system, because when you heat up the air, of course, it rises just like the smoke rising up off of a candle because of the convection cell that it creates. Now, the other thing that happens, of course, is that as the air mass is rising, it's carrying any moisture that's with the air to a higher altitude. And this is all a byproduct of focused energy that's coming from something like a phased array field of antennas, like the HARP system. Now, I know a fellow who actually worked on the HARP system, and he tells me that there are at least 17 other systems like that are placed around the world at very strategic locations. And so it's very clear that there is some kind of a coordinated program that's involved with the use of this particular kind of technology. And so, I can see where weather could be weaponized in this way. It could also be used as a way to steer powerful hurricanes away from highly populated areas. So you reduce the amount of property damage, you reduce the amount of injuries or casualties caused by a powerful weather system like that. You could even use it to suppress the activity in, say, a hurricane, for example. You might be able to create a counter rotation adjacent to the hurricane and steer it away from a particular populated area. You might be able to actually use this kind of a system to be able to heat up an area within the storm so that you basically throw it off balance, like removing the balancing weights from a wheel on a car so that it begins to wobble and it goes off course. So there's a lot of things that you could do in a useful way that might be helpful to mankind, but it's also something that can be used in a very destructive way. And part of what people don't understand in terms of the significance of HAARP and systems like HAARP is that you're taking what amounts to a lot of little tiny antennas, little smaller systems that are not as powerful, that don't handle the amount of energy, and you're just combining all of the total power emitted by that array by focusing it and causing it to arrive at the same location at the same time. That's really all you're doing. And so in a way you're creating a system that on the surface doesn't seem like it's all that threatening, and yet the combined energy of all those antennas could actually blow out the avionics on an aircraft and cause an aircraft to crash too, if you know exactly where the aircraft is and you can target it very precisely along its flight path. So these are things that I think most people don't imagine or understand as being possible, but it's completely within the realm of run-of-the-mill physics. These are things, most of this kind of technology has been around for quite a while, but it's never been incorporated into a single system or used as a means of projecting force to the degree that I think it's being used right now.
That sounds that Nikola Tesla's ether physics has progressed quite well in the last century. Now, I would like to, I just interviewed Elana Freeland, who wrote the book Chemtrails, HAARP and the Full Spectrum Dominance of Planet Earth. And I'm reading right now the book Weather Warfare, the Military's Plan to Draft Modern Nature by Jerry E. Smith. And in that book, it also talks about HAARP and the microwave energy and the amplification effects, and also some links to Thomas Bearden's work, scalar electromagnetics and so on. But he talks about maybe unnoticed, unseen collateral damage. For instance, Colombia, he wrote about it might have been that he's in a way explaining that it's not like a laser beam, very coherent, focused beam of information, that it also has a dispersal, so by which he means that sometimes when you direct at a point because you want to influence the atmosphere or you want to ruin a missile coming in or whatever, if the missile, for instance, is pointed at a spacecraft or another airplane, then what to do, because you want to get to the missile, but if your normal plane which you want to protect, or your normal aircraft or whatever, is in the vicinity of that influence field, so to speak, it would also get ruined. So how does that work? The very focused beam of information, like a laser, but of course it's way more than just laser or maser technology, and the fact that you might also hit airplanes or special craft you would like to protect the incoming missile from.
Well, as you may remember, during the Cold War, there was always the discussion of a possible nuclear war between the superpowers, between the Soviets and the United States, or the Chinese and the United States. And so a lot of the aircraft that were used by the military had electrical systems that were shielded to protect them from the electromagnetic pulse that would be produced by the detonation of a nuclear weapon. And so there are ways that you can shield the electrical systems of aircraft, and I believe that there's probably more of that going on now within the civil aviation community for commercial airlines and so forth. Not so much for smaller aircraft, but for larger commercial carriers, because many of these same aircraft eventually see application in the military. For example, the Boeing 707 passenger jet was essentially the same platform that was used for the Air Force throughout the 60s, more the 70s, even into the 80s, and a little bit later for air-to-air in-flight refueling as the KC-135. So, you have to understand that there are ways to target an individual aircraft in a particular area, but when you're talking about a system that has a much greater regional influence in the environment, like the HARP system, and combined with aerosols of different types, I don't think you're going to have that degree of precision in terms of being able to destroy a particular aircraft unless the aircraft itself is isolated well enough that using that particular kind of a system would be effective in taking it down. So I hope I answered your question.
I think so, and I think a lot more. There's one question, really the last question. You wanted me to continue with the HARP thing, so don't blame me. But there's one practical question. I think the answer can be quite short. What kind of planes, if we talk about chemtrails, of course, do you think they are using? Just military planes, but also commercial planes, or?
Well, I think it's a combination. I have seen not only military aircraft like the KC-135. They have a more recent version of the aircraft that has a larger, more efficient, high bypass turbofan engine that they're now using, and I've seen that particular type of aircraft. I've also seen Boeing 747s. I've seen some of the larger four-engine Airbus commercial carrier aircraft blowing aerosols, but the one aircraft that I see more than anything else here in Northern California is the Boeing 737-800, which is it's noteworthy because if you happen to have a powerful telescope or a set of binoculars that you can see this aircraft, the 737 is characterized by the fact that the main landing gear that are right under the center of the aircraft, where the wing is, the main wing, when those landing gear, I should say, are retracted into the fuselage of the aircraft, you can still see part of the tires exposed on the underside of the aircraft. The newer models, the Dash 800 version of the 737 has the little fins out on the wingtips also, which is something that you see in a lot of the telephoto shots that people are making of these aircraft spraying the aerosols. And so, but I've also seen a Boeing 767 that was leaving an aerosol trail that was being blown from the entire trailing edge of the main wing, not just the engines, but the entire wing itself, like a crop duster. And that, for me, was the one final piece of evidence that I needed to see to establish, in my mind anyway, that this isn't just something that's a phenomenon with the heat of the engines and the moisture in the air and that kind of thing. This is something that's being added to the atmosphere by a system in the planes themselves.
Yeah, in that case it was very obvious. Is the reason they can keep this secret because mostly the planes that are spraying the aerosols are military planes?
Well, no, I think that in reality, I think that the vast majority of the aircraft that I've seen producing the aerosols appear to be commercial carriers.
And do the pilots know, or maybe it's just putting in?
I don't see how they cannot know. I don't see how, particularly a seasoned pilot who's been flying for a decade or more. I don't see how one of these pilots can look at what's coming out of the aircraft that are flying out ahead of him, maybe at a slightly different altitude, can look at what's going on and not wonder if there isn't something just a little bit unusual about a condensation trail that does not dissipate, but in fact spreads out and becomes an entire cloud formation all by itself. The thing that makes the problem so much greater is what you were mentioning before, John, and that is what they call plausible deniability. Mm-hmm. The idea that during the Second World War, for example, the Boeing B-17 bombers that flew over Europe on the different missions would leave these tremendous long condensation trails, and part of that was because you're talking about turbocharged radial engines that had water injection, and so there was actually a lot of steam being produced inside the engine to extend the range of the aircraft by injecting water as part of the induction charge that was going into the engines. And so that was truly an example of condensation trails that hung around for a lot longer by virtue of the fact that they had water injection. The C-5A Galaxy, one of the largest aircraft in the world, in fact uses water injection as part of the operation of its engines. So there are systems that will produce condensation trails that last for a long time, but you shouldn't see a trail that lasts for hours. Or becomes larger over time, or as it's being dissipated by the winds at altitude, that it actually spreads out in these sort of striated, like strands of cotton being torn across the sky. There's some evidence that there are polymers that are being added to these aerosols that are used to keep the nanoparticles lofted in the air for longer periods of time, up to 2 weeks in some instances, from what I've read.
Or angel
yes.
hair? Yeah. Mm.
Yes. In fact, there have been a few occasions where I think the problem on occasion is that these strands of polymer material have to be mixed at particular ratios with the fuel and with everything else that's being sprayed out the back of the aircraft in order for them to dissipate and to help loft these nanoparticles for longer periods of time. But if you don't get the mixture quite right, you wind up with what are called chem webs. Now, several years ago, just a couple of years ago, on a Saturday, we had chem webs falling all over the community of Redding, California, where I live. In fact, I managed to collect a specimen of those, which I still have in my freezer right now. So I have seen this.
I hope you don't eat any food from your fridge.
Oh, no, I don't really eat much from my own household at all, mostly because there seem to be a lot of people that are not real happy with the fact that I've spoken out on some of the topics that I have, and so I always consume my food somewhere else.
I understand.
But the interesting thing, the quality about these strands of material was that it was pure white in color. It had a very fresh, organic look to it, almost like spider webs that were thicker, and it had kind of a wavy texture to it also at a small scale. And when I collected the specimen, and this is something that I would suggest to anyone who comes across this kind of material, do not touch it with your hands. Do not let it get on your skin. If you're going to pick it up, put it into a sterile container. Use some kind of metal appliance like a stainless steel knife, or some kitchen utensil that you will not use again until after it's been thoroughly cleaned with hot water and soap and so forth. But do not touch this stuff with your hands.
Okay. Well, I think we covered the whole chemtrail geoengineering hard thing here. Mark, it's such a nice time talking to you, and what an amazing insights and knowledge you have, and I would like to appreciate your time and your expertise, because we, like I mentioned to the listeners, we just wanted to have a little bit of comments about the chemtrails. I had all the time, so we can talk for hours, but I know you had to go to bed like probably already a few hours ago. So once again, I would like to thank you for your time and your perseverance, and I would love to have you come over here and join us in Amsterdam with a conference about anti-gravity and free energy and ether physics. But we'll talk about that a little bit more in the future. For now, I'm signing off. My name is John Consemulder. Go to healingsoundmovement.com, tv.healingsoundmovement.com, worldpeacechild.com. But first and mainly, of course, go to markmccandlish.com. And Mark, hold the line for just 1 minute more. But for now, I want to say bye-bye to our listeners. And thank you, Mark, for this amazing talk.
Thank you for having me, John. I really appreciate it.
Thank you.
Which